Hello and welcome. In today's video, we will discuss about generative models. So we will explore more on the models, the kind of AI that powers tools like ChatGPT, Google Gemini, and Claude. If you have ever wondered how can AI write an easy answer, summaries to questions, or even write application coding, then this is the video for you. By the end, you will understand how these AI models learn to talk, write, and think, although something called generative modeling. So let's get started. What are generative language model? Imagine you are texting your friend and typing I am feeling really followed by blank. You already have a few words in mind like happy, tired, hungry. Now imagine a machine that can also guess what comes next, not just one time, but millions of times for any sentence. That is what a generative model does. It generates text by prediction, one word at a time, based on the words before it. So if you say the sun is shining and the birds are and leave a blank, it might continue with singing in the trees. So it learned this pattern by reading billions of sentences from books, website, blogs, and conversations. So generative model generate text by prediction, one word at a time. They power tools like ChatGPT, Anthropic Claude, and Google Gemini based on decoder-only transformers. And how do we train these generative models? Like we have seen in prior video, models trained on massive text datasets using casual language modeling and then predicts next word step by step to learn the language structure, uses cross entropy laws to measure performance. Let's look into how it works. Decoder only transformers. Generative models use a special type of AI architecture called as transformers, and more specifically, a decoder only transformer. So let's break down into the major parts. The decoder means it creates something new like words or sentences. It looks what had already been given as input and decides what comes next in the sentence. Autoregressive generation, which means it generates one word at a time, building a sentence step by step. Think of it like a Lego block. You start with one, then add the next block based on the existing data until you build a whole castle, or in this case, a paragraph. So how do we train generative model? Training a model is a lot like teaching a student how to write. Here is what we do as part of training model. Feed it a tons of text, like every book in a library, every article in a Wikipedia, or every blog post that we have over internet. Mask the last word of the each sentence and ask the model to guess it. If it guesses wrong, we correct it. So that's how it gets trained on the prediction. Do this billions of times and it slowly gets really, really efficient. For example, if it says the cat is sitting on the followed by blank and it learned the most likely word is a wall or a mat or a table. This process is called self-supervised learning because the model teaches itself by learning from patterns in text. So what is goal of the training? The major goal is to fine tune it. So fine tuning LLMs for specific tasks that are adapted to tasks like legal writing or even summarization. Fine tuning adjusts internal parameters like task specific examples. So let's see aligning models with the real world. Just like a student that might say something innocent without knowing, models can also make mistakes. That's why we align them with human values, teaching them to be helpful. So the alignment ensures models are helpful and safe. This is done using a method called reinforcement learning from human feedback. Often it is termed as RLHF, where humans give a thumbs up or a thumbs down on responses and the model learns from that feedback. It's like a teacher guiding the student toward better future responses. So it ensures ethical constraints to the model usage. So next we will see about prompting LLMs. Natural language prompts tell the model what to do, and few short prompting uses examples to guide the model. So what is prompting? Talking to the model. Here is something cool. You don't need to retrain the model to change how it behaves. You can just change the way you ask. That's called prompting. Say you want a summary of a story, you can prompt the model like summarize the following text or summarize the given input or summarize a document. Or if you want to translate something, translate to French and give a sentence saying good morning. And it translates into the language you asked. You can even show few examples in your prompt that is called few shot prompting. And if you don't give examples, that's zero shot prompting. The model still tries to guess what to do based on the instructions alone. So, in simple terms, prompting is like giving instructions. Think of a model as super smart student who is ready to do any task, but you need to be very clear with your instructions. The better you prompt, the better the output you will able to get from the AI tools. Now let's see scaling up bigger models for better results. Before that, we will discuss about training at scale. That is, large models have billions and trillions of parameters. That is why they are termed as large language models. And it involves data prep, distributed training, and scaling laws. In my case, bigger models perform better, they understand more and make fewer mistakes. But training these giant models take a lot of computing power and efforts. To handle that, researchers found few steps like split the work across many computers, which are also termed as GPUs. And the second, use smart training tricks like mixed precision or gradient checkpointing. And the third, apply scaling laws to know when a bigger model is worth of it. This is how we get the models with billions or even trillions of parameters. That is nothing but neurons of AI. So uses attention optimization and memory caching for modeling long sequences. Handles long text like articles and conversations. And what is long reading long tests? LLMs have a limit. They can only see a certain number of words at once. So what happens when the text is long? We use clever techniques like chunking, memory caching, sharing parts of model. So what is chunking? The input into smaller parts and using memory cache to remember earlier content, sharing parts of the model across the layers, the which is to reduce the size. This way the model can handle long conversations, huge size documents and very long articles without getting confusion. The important things chunking, memory caching the previous content and model across layers. So parameter sharing makes large models more efficient, reduce memory usage and training complexity. So let's summarize what we have discussed till now. Generative models are AI that write and create text by predicting the next word, but only one next word at a time. They use decoder only transformers like GPT. Transformer, which is nothing but all models that are available in the library. Training involves reading lots of text and learning word patterns. We fine tune for specific jobs and align them with human values. Prompting helps guiding the model behave, which is untrained, bigger models, and better training for smarter AI. Special techniques help the model handle longer input like chunking, memory caching, and modeling across layers. So that's all about generative models for now. We have gone from what a generative model is all the way to how do we train, fine tune, and prompt them. If you found this video helpful, give us a like, subscribe, and comment with your questions. We love to help. Thanks for watching, and I'll see you in the next chapter.